Hi guys, this is Paul with Tweaktown. We're back here at Flash Memory Summit 2014. Right now we're sitting down with Andy Mills. He is the CEO at Enmotus. And a lot of people right now are looking for a great way to extract more value from Flash. And sometimes that involves taking advantage of existing infrastructure, hard disk drives. Everybody wants to kind of slap a front end on there with some speedy storage and kind of combine the two. Can you tell us kind of your approach to providing a solution for that?
Sure. We're a software company, so we really wanted to stay away from being another flash device. So we decided what we wanted to do is take fast devices, slow devices, and really make it very easy for people to integrate those in. So take a flash device, for example, or an NVDIMM device like we've been talking about with at the show here with Viking, for example, a PCIe SSD. Take that, put it in a system. Today it's still an island, potentially an island of storage. What we wanted to do is integrate that with your back-end storage, but make it, instead of a cache, make it a full-blown primary storage tier. The benefit of that is you get full read-write access to that device, and that device now becomes operating pretty much at the full speed of the SSD. Our cache typically maxes out. So we thought we'd take that approach because it's a storage virtualization approach. It's borrowing ideas from big iron storage, bringing it down to the simplicity of a software solution you can drop into a Windows or Linux environment.
And you're setting on the block, you use a block storage, correct?
Correct, yes. We're sub-file, sub-LUN, sub-hypervisor, whichever way you want to look at it, we're sub. We're so low, we actually don't even use filter drivers. We go right into the guts of the kernel. We're a driver in Windows, we're a driver in Linux, but we do have a couple of helper applications. For example, file pinning. You can't do that without knowing what the file is, but we have some very clever mapping tools to be able to show you how you can map that down to a block device. We tell our block engine to go, hey, move this stuff, but it's all done invisibly to a user and done incredibly easily.
So in one instance, it's automated. I mean, you really don't have to do anything. You can just sit back and let it do its job.
Yep.
But if the user decides, then they can pin an item into the SSD, into the cache.
Correct. And in fact, we've had people say we like the idea we can stop something going to the cache. So you can pin it in the slow tier as well. So
really?
For example, if you've got a music file someone keeps playing, you don't want it cached, just right click, say never go to top cache. It's as easy as going into Windows Explorer, right click your file, say no thank you. So we have a filtering mechanism that can stop that at file level, but we still operate at the block layer.
So when you guys are combining these, and it's not necessarily flash, it's just any speedy device, you're pretty much vendor agnostic when it comes to the hardware?
That is correct, yes. We wanted to maintain a high degree of vendor agnostic, and also device agnostic. So the fact we can support NVDIMM now as we're moving forward, but PCIe SSDs, we can even pool a few of these PCIe SSDs. You can even take different vendors' SSDs and pull them together, and then tier them with your back-end hard drive.
That's great. And sometimes some people are a little bit concerned when it comes to caching and tiering about possibly losing some data in that tier. What kind of steps can people take to protect data in the flash or NVDIMM tier?
Sure. So as a primary storage architecture versus a cached architecture, which makes a copy, we tend to make a full move into the data tier in our full tiering architecture. So in that case, we're going to tier a rated set, for example, of an SSD. So you take two SSDs, mirror them, use your favorite RAID vendor, LSI, Adaptec, a software RAID, even Windows storage spaces, and you're going to tier that with a second set that you've created, and that could be a set of hard drives in RAID 5, RAID 6, and you let that handle the underlying redundancy, as it were, and then we just act as the tier on top.
So that should allow users to retain pretty much the full functionality of their device.
Correct, and we'll even migrate in your old existing volume if you're converting a volume. So for example, if you wanted to have you had a RAID 6 set and then you're running out of steam, you can actually add your RAID 1 set of SSDs, convert that to a tier, and retain all your data without losing it. So we've made it, again, very easy for people to take it over, but give them the benefit of having SSD performance in their system.
And what kind of host overhead? Sometimes caching engines especially have been known to eat some cycles. What kind of cache overhead, excuse me, not cache overhead, but what kind of host
CPU overhead?
Yes.
Overhead. We're going to take a little, of course, but we tend, the difference in architecture, a cache is inline. It's always taking a decision, making decisions as the data is coming through. We've taken a different approach where you have a get in, get out, very, very fast architecture. architecture, you just say, tell me where it is. And then after the fact, in the background, we move data. So a true tier, a two virtualization plus tiering architecture is very different to a cache in the sense that it moves data after the fact. So in some cases, a cache might behave a little better, but the difference is, back to your CPU question, is we take very little overhead because it's a small blip. So you might get a 1 or 2% impact while it's making the decision, but after that, once it's mapped and it's on the SSD, it's no overhead. It's almost zero. It's just that 1 microsecond latency we may add just to go look aside, look where it is, go steer the data to that location.
And so we're seeing some of this move right now into, flash is a big part, especially here at this show, but people are looking for that next level of performance. So we're starting to see NVDIMMs and things like that come out. And I know that you guys are doing a demo here with Viking, correct?
Yeah.
Can you give us a little word on that?
Sure, yeah. I mean, this is a very beginning of a good relationship, we hope, of course, and between our companies. And what we're demonstrating here is in our lab, we've been able to take their NVDIMM. Typically they've used as a cache, or something like that. We've been able to make it a full tier for someone as well. So in this case, we've been able to demonstrate almost 1 million IOPS just straight off, just playing with this thing through our tiering engine.
Wow.
Combined with a back-end array of hard drives. The first comment, though, from people wasn't, wow, you're going fast. It's like, you mean you made it appear as a single normal disk drive?
Yeah.
That was the biggest piece. It was the integration. So when we talked to our partners on the other side of the equation, the system vendors, they said that's made our life so much simpler. And especially if you can use that same piece of software to handle PCIe SSDs and normal SSDs and hard drives. So they like the idea that you've got a range of vendors and a range of performances. So 1 million IOPS down to, whatever you want to put in a cheap 10,000 IOPS device, we don't care.
Yeah, so you could use maybe even possibly NVDIMMs to cache for SSDs because they can absorb that write workload.
Perfect, absolutely. I think, in fact, we see NVDIMMs because they behave more like RAM. That's the nice thing. So we see them actually being used a lot as a write, like a write buffer or a write cache. Now we have very high write performance in our engine because you're a direct write path into that storage. So we see there's some huge benefits for ingest going forward, being able to ingest data very quickly and then later push them into tiers. And because we're an intelligent tiering engine, we have policies that define these things. You can decide that data arrives here and ends up over there, or starts here and ends up over here. The important thing is you give the user either a fully automated push button approach or you give them the ability to steer that data with policies.
And when they're adding drives, they're actually adding capacity. In a lot of cases, people really don't like that.
That's right.
They add SSDs and they lose capacity.
They lose it, yeah. In fact, our favorite question was always from the cache users, where did my SSD go? And I didn't even see the performance in some cases, but where did it go? I mean, we know caching and tiering sometimes doesn't always deliver the full performance benefits, but we found actually the exact opposite. You get to see the performance benefit and you get to see the capacity, which is great.
That's good, yeah. You get a little bit of both, best of both worlds.
Yeah.
Well, that's exciting, and we're going to stop by your booth tomorrow, guys, and we're going to have some video of the demo up, so keep your eyes out. Thanks for stopping by.
Really appreciate it. Thank you.